Santorini earthquakes, a ticking time bomb in disguise. What if one of the most beautiful places on Earth was sitting on a ticking time bomb? Beneath the whitewashed walls and sapphire blue waters of Santorini lies a volcanic system that could change everything. Santorini might be the quintessential postcard-perfect island, but its beauty is a product of one of the most powerful forces on Earth: volcanic activity. To understand why scientists are keeping a close eye on this Greek paradise, we have to start with what's going on beneath its surface. This place is part of the Hellenic Volcanic Arc, a chain of volcanic islands formed by the ongoing collision of two massive tectonic plates. Imagine the Earth's crust as a giant jigsaw puzzle, with pieces constantly shifting and reshaping the surface of our planet. In this case, the African plate is slowly being forced under the Aegean Sea Plate in a process called subduction. This process doesn't just create mountains and trenches, it also generates intense pressure and heat, melting the Earth's crust and forming pools of magma deep below the surface. Over millions of years, this magma has risen up, creating the volcanic islands we see today, including Santorini. Now, Santorini isn't just any volcanic island. It's a geological masterpiece with a dramatic history. Thousands of years ago, the island was the site of one of the largest volcanic eruptions in human history, the Minoan eruption. This catastrophic event, which occurred around 1600 BCE, obliterated much of the island, leaving behind the massive caldera that defines Santorini's iconic crescent shape. This wasn't just an ordinary eruption. It was so powerful that ash from the explosion has been found as far away as Greenland and Egypt. Some researchers even link the event to the downfall of the Minoan civilization and the legend of Atlantis. The caldera itself is a fascinating geological feature. Picture a gigantic bowl, nearly 12 kilometers wide, formed when the volcano's magma chamber emptied during the eruption, causing the land above to collapse. Today, this caldera is mostly underwater, with the island's cliffs forming its rim and offering those jaw-dropping views that tourists flock to see. But what's important to note is that this caldera isn't a relic of the past. It's still active, with a magma chamber lurking just below the surface, constantly evolving and recharging. And Santorini's volcanic story doesn't stop there. Just a few kilometers to the northeast lies the Colombo submarine volcano, a lesser-known but equally important player in the region's volcanic drama. Colombo is part of the same volcanic system as Santorini and has its own history of eruptions. The most recent one occurred in 1650 when Colombo erupted underwater, killing hundreds and releasing toxic gases. Scientists have discovered that Colombo's magma chamber is growing, with some estimates suggesting it could erupt again within the next 150 years. This close relationship between Santorini and Colombo is a critical factor in understanding the risks that the region faces today. So what makes Santorini's volcanic system so dangerous? It's all about the magma. Beneath the island, there's a complex network of magma chambers and dikes, essentially magma-filled cracks, that connect the different parts of the volcanic system. These chambers don't just sit there quietly. They're constantly being fed by deeper sources of magma from the Earth's mantle. As magma rises, it increases pressure within the system, creating the potential for an eruption. But here's the catch. This process doesn't always give clear warning signs. Sometimes the ground might swell, or there might be an increase in seismic activity. But other times, eruptions can occur with little to no warning. And speaking of seismic activity, Santorini is no stranger to earthquakes. The same tectonic forces that fuel its volcanoes also make it one of the most seismically active regions in Europe. Earthquakes in the area can be caused by the movement of tectonic plates, the shifting of magma underground, or a combination of both. These quakes are not just an indicator of volcanic activity, they can also trigger landslides, tsunamis, and other secondary hazards. It's this combination of factors, a volatile magma system, a history of massive eruptions, and constant tectonic activity that makes Santorini such a fascinating and dangerous place. Scientists are particularly concerned about the shallow magma chamber beneath the caldera. Recent studies have shown that this chamber is expanding, which could mean that the system is recharging for another eruption. And while it's impossible to predict exactly when or if this will happen, the potential consequences are significant. Santorini's geological story is far from over. Beneath its stunning surface lies a dynamic, ever-changing system that has shaped the island's past and will continue to define its future. Understanding the geology beneath Santorini isn't just about unraveling the secrets of the past. It's about preparing for what might come next. I'm sure you're wondering, how does a volcano let us know when it's about to erupt? Does it send smoke signals? Does the earth grumble beneath your feet? Or maybe it's a combination of subtle and not so subtle signs that scientists have learned to track over time. In Santorini's case, there are indeed warning signs that hint at potential volcanic or seismic activity, but the tricky part is interpreting them in time. Santorini's volcanic system is like a sleeping giant that occasionally stirs, and when it does, it can give off some pretty dramatic signals. One of the most obvious signs is seismic activity, earthquakes. Volcanic earthquakes, also known as earthquake swarms, are clusters of small tremors that occur when magma moves through cracks in the Earth's crust. Think of it like trying to squeeze toothpaste through a tiny clogged nozzle. You'd probably feel some pressure build up before the toothpaste squirts out. For the topic of this episode, these swarms often occur beneath the caldera or near the Colombo submarine volcano, indicating that magma is on the move. In recent years, Santorini has experienced an uptick in seismic activity. In fact, between 2011 and 2012, thousands of micro-earthquakes were recorded beneath the island, and scientists found that the ground had risen up by 14 centimeters in some areas. This is what geologists call ground deformation, a telltale sign that magma is accumulating underground and pushing the surface upward. While this doesn't mean an eruption is guaranteed, it's a clear signal that the volcanic system is active and evolving. But earthquakes and ground deformation aren't the only clues. The volcanic system also breathes, emitting gases from cracks in the earth. These gases, which include carbon dioxide, CO2, and sulfur dioxide, SO2, are released when magma approaches the surface. Measuring these emissions can give scientists a glimpse into what's happening underground. For instance, a sudden spike in sulfur dioxide levels could indicate that magma is rising and that an eruption might be on the horizon. During the 1650 Colombo eruption, toxic gases were released into the atmosphere, causing widespread casualties. Today, monitoring these gases is one of the key tools scientists use to assess volcanic risk. And it's not just the land and air that provide clues. What's happening beneath the sea is just as important. The Colombo submarine volcano has been a focal point of recent research, and for good reason. In 2006, scientists discovered that Colombo has a growing magma chamber about 3 kilometers below the sea floor. This chamber is expanding at a steady rate, and some experts estimate that it could erupt within the next 150 years. While that might seem like a long time, in geological terms, it's just a blink of an eye. The idea of an underwater eruption might sound less dramatic than a volcanic eruption on land, but it comes with its own set of dangers. When Colombo erupted in 1650, it created a massive tsunami that devastated nearby islands. If the volcano were to erupt again, it could trigger similar waves, posing a threat not just to Santorini, but to the entire Aegean region. And because Colombo is underwater, it's harder to monitor than land-based volcanoes, making it a particularly tricky hazard to predict. Of course, scientists don't rely on just one or two methods to monitor Santorini's volcanic and seismic activity. They use an arsenal of cutting-edge technologies to keep a close eye on the island. For example, satellite geodesy and INSAR, interferometric synthetic aperture radar, are used to measure even the tiniest changes in land elevation. These tools can detect ground deformation with millimeter precision, providing invaluable data on magma movement. Another key tool is seismic monitoring, which involves placing seismometers, devices that measure ground vibrations, across the island and on the sea floor. These instruments can pick up everything from tiny tremors to larger quakes, helping scientists map the underground magma pathways. And more recently, artificial intelligence and machine learning have been employed to analyze seismic data and identify patterns that might indicate an impending eruption. But while technology has come a long way, predicting volcanic eruptions is still far from an exact science. One of the challenges is that volcanic systems like Santorini's don't always behave consistently. For instance, the 2011-2012 seismic swarm and ground deformation eventually subsided without leading to an eruption. This underscores just how complex and unpredictable these systems can be. History, however, gives us some important clues. The Minoan eruption was likely preceded by months or even years of seismic activity and ground uplift. Similarly, the 1650 Colombo eruption was foreshadowed by earthquakes and gas emissions. By studying these past events, scientists hope to better understand the warning signs and timelines of future eruptions. Here's the big question, though. How much warning would we actually have? Some volcanic eruptions, like Mount St. Helens in 1980, are preceded by weeks of clear warning signs, while others, such as the eruption of New Zealand's White Island in 2019, happen with little to no notice. In Santorini's case, the combination of seismic activity, gas emissions, and ground deformation would likely provide some lead time, but there are no guarantees. What would you do if you were on Santorini and suddenly felt the ground shake? Would you trust the science and wait for updates? Or would you pack up and leave immediately? Let us know in the comments below. Your answer could spark an interesting discussion. No one can deny it. The signs of potential volcanic or seismic activity in Santorini are all around us, from the rumble of earthquakes to the subtle rise of the ground. But interpreting these signs is a delicate dance between science, history, and the unpredictable nature of Earth itself. What's certain is that Santorini's volcanic system is alive, and it's only a matter of time before it reminds us of its power once again. The big question on everyone's mind is, how likely is a natural disaster in Santorini, and what would it look like if it happened? Predicting the exact timing of an earthquake or volcanic eruption is one of the most challenging tasks in geology. It's not like forecasting the weather, where you can rely on data patterns and models to give you a reasonable estimate. Volcanoes, especially ones as complex as Santorini's, operate on geological timescales, events that can happen suddenly after centuries of dormancy. But thanks to advanced monitoring systems, scientists have gotten better at spotting the warning signs. So how close are we to an event? And what would happen if the system erupted? Let's start with the current state of the volcanic system. Recent studies show that Santorini's shallow magma chamber beneath the caldera has been recharging steadily over the past few decades. Think of it like filling a balloon with water. At first, the pressure inside isn't enough to cause any problems, but as the balloon keeps inflating, it eventually bursts. In Santorini's case, that burst would be an eruption. The tricky part is that we don't know how much pressure is needed to trigger it or how quickly magma is entering the chamber. What we do know is that this chamber is connected to deeper magma reservoirs, meaning there's a steady supply of molten rock feeding the system. Then there's Colombo. Its growing magma chamber is a major wild card. An eruption from Colombo could be just as devastating as one from Santorini's caldera, if not more so. Because it's underwater, an eruption could displace massive amounts of water, triggering tsunamis that could travel across the Aegean Sea. Imagine standing on the beaches of Santorini, staring at the calm, blue horizon, only for the water to suddenly recede. An eerie silence before the ocean comes roaring back with unimaginable force. This is what makes the Colombo volcano so dangerous. It's not just about lava and ash. It's about the cascading effects that one event can set off. So, how likely is an eruption or earthquake in the near future? The probability depends on the interplay of magma movement, tectonic stress, and pressure buildup. Experts have estimated that Colombo could erupt within the next 150 years, but that's just an educated guess based on current data. Similarly, the shallow magma chamber beneath Santorini's caldera is showing signs of activity, but there's no way to pinpoint when or if it will erupt. What's important to note is that both systems are active, and activity means risk. Even without a volcanic eruption, earthquakes remain a constant threat in the region. Santorini's location near the subduction zone of the African and Aegean plates makes it one of the most seismically active areas in Europe. A major earthquake could trigger landslides or even destabilize the volcanic system, increasing the likelihood of an eruption. And it's not just localized damage. Historical records show that earthquakes in the Aegean Sea have sent shockwaves across the Mediterranean, affecting regions as far away as Crete, Turkey, and even Italy. The potential impacts of a natural disaster in Santorini could be devastating, both locally and globally. Locally, an eruption or earthquake could destroy infrastructure, disrupt tourism, and force the evacuation of thousands of residents and visitors. Think about it. This major destination attracts millions of tourists every year, many of whom are concentrated near the caldera. In the event of an eruption, ash clouds could ground flights, tsunamis could sweep through coastal areas, and gas emissions could make the air unbreathable. Globally, a significant eruption could disrupt weather patterns, as volcanic ash and gases enter the atmosphere and reflect sunlight. The Minoan eruption is believed to have caused a volcanic winter, disrupting agriculture and civilizations far beyond Greece. But it's not all doom and gloom. The good news is that scientists are better prepared than ever to monitor and respond to volcanic and seismic activity. The Multi-MERIX project, for instance, has deployed high-tech sensors on the seafloor and throughout the region to track seismic activity and gas emissions in real time. Instruments like satellites and seismometers are constantly collecting data, and artificial intelligence is being used to analyze patterns and identify potential warning signs. These tools give us a better understanding of what's happening beneath the surface, allowing for quicker responses if something changes. That said, the region's preparedness is still a work in progress. Santorini's popularity as a tourist destination means that evacuation plans and public awareness campaigns are essential. If an eruption or major earthquake were to occur, clear communication would be critical to ensuring safety. Governments and scientists are working together to balance the risks with the island's economic reliance on tourism, but there's no denying the challenges of protecting such a densely visited area. So what's the takeaway? Volcanic and seismic activity is a reminder of the Earth's raw power and unpredictability. Beneath its idyllic surface lies a dynamic system that has shaped not just the island's landscape, but also its history and culture. The potential for another eruption or earthquake is real, but so is the effort to understand and mitigate those risks. As much as we love to admire Santorini for its stunning beauty, it's important to remember what lies beneath: a natural force that has the power to both create and destroy. While we can't control the Earth's movements, we can learn from its signals and prepare for the future. If you enjoyed diving into the science and mysteries of Santorini's geology, don't forget to hit that like button and subscribe for more fascinating explorations. And as always, stay insanely curious.